Since the dawn of civilization, humanity has looked up at the night sky in wonder. The cosmos, an endless ocean of stars, planets, and galaxies, has inspired myths, fueled scientific discoveries, and raised some of the biggest questions of all: where did we come from, and are we alone? The vastness of space stretches beyond comprehension, and even with all our advancements, we have only begun to scratch the surface of understanding the universe. In the grand scheme of cosmic time, human existence is but a fleeting moment. Yet, in that moment, we have evolved from stargazers to space travelers, reaching beyond our world to explore the unknown. From the first telescopes to the monumental moon landing, our journey into space has been driven by curiosity, ambition, and a relentless desire to push the boundaries of what is possible. The story of space exploration is one of triumph and tragedy, mystery and revelation. NASA, the pioneering agency of human spaceflight, has taken us to the moon, sent robotic explorers to Mars, and ventured beyond the edges of our solar system. But with great discovery comes controversy. Were we told the full truth about the Apollo missions? Are there secrets hidden beyond the stars that NASA won't reveal? The mysteries of space travel run deeper than many realize, and with every new mission, the unknown beckons us forward. Beyond our own efforts, the universe itself holds secrets that defy explanation. Black holes, cosmic voids of unimaginable gravity, warp time and space, consuming anything that crosses their event horizon. Neutron stars, the remnants of massive supernovae, spin at mind-bending speeds, pulsing like cosmic lighthouses across the void. And then there are the exoplanets, thousands of worlds beyond our solar system, some eerily similar to Earth, raising the question, could life exist out there? As we continue our journey into the stars, the challenges of space travel become ever more apparent. The dangers of radiation, the psychological toll of isolation, and the immense distances between celestial bodies present obstacles unlike any we've faced before. Yet, the dream of colonizing other planets persists. Mars, our closest neighbor, is seen as the next great frontier. But is it truly habitable? And if humans do establish a colony there, what kind of future will we create among the stars? This is the story of space, the mysteries of the cosmos, the rise of NASA, and the future of interstellar travel. Over the next few hours, we will embark on a journey through history, science, and speculation. We will explore the triumphs and failures of space exploration, the conspiracy theories that surround NASA, and the awe-inspiring beauty of the universe itself. So sit back, relax, and let your mind drift into the vast expanse of the cosmos. The journey is just beginning. The universe is a vast and silent expanse, stretching far beyond what the human mind can comprehend. For centuries, we have looked to the stars, searching for answers, trying to understand our place in the grand cosmic puzzle. The night sky, once thought to be a fixed dome of twinkling lights, is now known to be an ever-expanding ocean of galaxies, nebulae, and celestial wonders, each one holding secrets waiting to be uncovered. Our journey into space began long before rockets and satellites. Ancient civilizations tracked the movement of the stars and planets, using them to mark time, navigate the seas, and predict the changing seasons. The Babylonians recorded the positions of celestial objects on clay tablets. The Egyptians aligned their great pyramids with the stars. The Mayans built precise astronomical calendars, and the Greeks laid the foundation for modern astronomy, theorizing about the motion of the planets and the nature of the cosmos. But for most of history, the universe was a mystery we could only observe from afar. That all changed in the early 17th century when Galileo Galilei pointed a telescope at the heavens and saw things no human had ever seen before: mountains on the moon, moons orbiting Jupiter, and a universe that was far more complex than anyone had imagined. His discoveries challenged the long-standing belief that Earth was the center of everything, setting the stage for centuries of exploration and scientific breakthroughs. Fast forward to the 20th century, and our understanding of the cosmos took another giant leap forward. The invention of rocketry made it possible to escape Earth's gravity, paving the way for a new era of space exploration. The Cold War rivalry between the United States and the Soviet Union ignited the space race, a competition that would push technology and human endurance to new limits. In 1957, the Soviet Union launched Sputnik, the first artificial satellite to orbit Earth. Just 4 years later, Yuri Gagarin became the first human in space, proving that we could survive beyond our planet. Not to be outdone, the United States accelerated its own space program, and in 1969, NASA achieved what many thought was impossible: landing humans on the moon. When Neil Armstrong took that famous first step, it was more than just a scientific achievement. It was a statement to the world that humanity was no longer bound to Earth. The moon landing remains one of the most significant milestones in human history, but even today, some question whether it happened as NASA claims. Were there hidden secrets behind the Apollo missions? Were all the details shared with the public, or was there more to the story than we were told? Beyond the moon, the cosmos stretches out in every direction, an unfathomable expanse of time and space. Our own Milky Way galaxy is just one of billions, each filled with countless stars and planets. Some of these planets may be lifeless, barren rocks, but others, perhaps many, could harbor life. The discovery of exoplanets in recent years has changed the way we think about our place in the universe. With each new discovery, the possibility of extraterrestrial life becomes more plausible. Could intelligent beings exist elsewhere in the galaxy? If so, have they already visited us? Some believe NASA knows more than they let on, hiding information about alien encounters and unexplained anomalies. The more we explore, the more mysteries we uncover. Black holes, with their immense gravity, can warp time and space itself, swallowing anything that comes too close. Pulsars, rapidly spinning neutron stars, emit beams of energy that sweep across the universe like cosmic lighthouses. Dark matter and dark energy, which make up most of the universe, remain invisible and largely unexplained. Even the very nature of space and time is still a puzzle, with physicists debating theories about parallel dimensions, wormholes, and the possibility that our reality may be just one of many. As technology advances, we stand on the brink of a new era of space exploration. NASA, along with private companies like SpaceX, is planning manned missions to Mars, aiming to establish a human presence on another world. But Mars is just the beginning. The dream of interstellar travel, of one day reaching beyond our solar system, continues to fuel our imagination. What challenges will we face? What dangers lie ahead? And will we ever unlock the ultimate mystery, the true nature of the cosmos itself? As we continue this journey, we will dive deeper into the wonders of space, the history of NASA, and the theories, conspiracies, and unanswered questions that make the universe so endlessly fascinating. From the secrets of the moon to the possibility of alien life, from the mysteries of black holes to the vision of a future where humans travel among the stars, this is our story. The story of space. And it is only just beginning. The birth of NASA marked the beginning of a new era, one that would forever change the way humanity interacted with the cosmos. Established in 1958, the National Aeronautics and Space Administration was formed in response to the Soviet Union's rapid advancements in space technology. With the launch of Sputnik, the world's first artificial satellite, the US government realized that it was no longer enough to simply observe the heavens from Earth. It was time to reach for the stars. NASA's early years were defined by both ambition and desperation. The space race was not just a scientific endeavor, it was a battle of ideologies, a symbolic struggle between democracy and communism played out beyond Earth's atmosphere. The Soviets took the lead, sending the first human, Yuri Gagarin, into space in 1961. His journey around the planet lasted just 108 minutes, but in that short time, he secured his place in history. The United States had no choice but to respond. The stakes were high, and the pressure to catch up was immense. Enter President John F. Kennedy. In 1961, he addressed the nation with a bold declaration: America would land a man on the moon before the decade was out. It was an audacious promise, considering that, at the time, NASA had yet to even send an astronaut into orbit. But the challenge was accepted. The Apollo program was born, a massive effort involving hundreds of thousands of engineers, scientists, and astronauts, all working toward a singular goal: reaching the moon. Before Apollo, NASA had to prove it could safely send humans into space and bring them back. The Mercury and Gemini programs laid the groundwork, testing spacecraft, maneuvering techniques, and the effects of space travel on the human body. Astronauts like Alan Shepard, John Glenn, and Gus Grissom became household names, their missions followed by millions. Each success brought NASA one step closer to its ultimate objective, but not without setbacks. The tragic Apollo 1 fire in 1967, which claimed the lives of 3 astronauts during a routine ground test, was a sobering reminder of the dangers of space travel. Yet, NASA pressed on, determined to fulfill Kennedy's vision. And then, on July 20, 1969, the moment arrived. Neil Armstrong and Buzz Aldrin stepped onto the lunar surface, while Michael Collins remained in orbit above. Armstrong's words, "That's one small step for man, one giant leap for mankind," echoed around the world. The impossible had been achieved. But almost as soon as the moon landing was broadcast, doubts emerged. Some people questioned the authenticity of the event. How had NASA managed such an extraordinary feat with technology less advanced than a modern smartphone? Why did the American flag appear to wave in the wind, despite the moon's lack of atmosphere? Where were the stars in the photos? These questions, along with inconsistencies in NASA's footage, led to speculation that the moon landing had been staged. Some believed it was filmed on a Hollywood set, directed by none other than Stanley Kubrick, whose film 2001: A Space Odyssey had demonstrated how convincingly space scenes could be recreated. NASA, of course, has always denied these claims, providing scientific explanations for the anomalies. The flag's movement was due to momentum from being planted in the lunar soil. The missing stars were a result of camera exposure settings. The shadows, though appearing unusual, were consistent with the moon's unique lighting conditions. Still, for many, doubt remained. If NASA had faked the moon landing, why would they do it? The most common theory suggests that the US government, desperate to claim victory over the Soviet Union, staged the event to solidify America's dominance in the space race. Regardless of the controversy, NASA continued its lunar missions. Between 1969 and 1972, 6 Apollo missions successfully landed on the moon, gathering data, conducting experiments, and leaving behind scientific instruments. Yet, despite these achievements, humanity has not returned to the moon in over 50 years. Some argue that budget constraints and shifting political priorities ended the Apollo program. Others suggest that something was discovered on the moon, something that NASA didn't want the public to know. Strange rumors have persisted over the years. Whispers of unidentified objects spotted by Apollo astronauts, mysterious transmissions intercepted during lunar missions, and even claims that ancient structures exist on the far side of the moon. Could it be that the moon is more than just a barren rock? Some theorists believe it may have once been home to an ancient civilization, or even that it is an artificial structure, possibly a hollow satellite placed in Earth's orbit by unknown forces. While these ideas may sound far-fetched, they continue to capture the imagination of those who suspect NASA knows more than it lets on. But NASA's mission did not end with the moon. In the decades that followed, the agency turned its focus toward deeper space exploration. The Voyager probes, launched in 1977, became humanity's first messengers to the stars, carrying a golden record filled with Earth sounds and images in case they were ever discovered by extraterrestrial life. The Hubble Space Telescope, launched in 1990, opened a window to the universe like never before, capturing breathtaking images of distant galaxies, nebulae, and cosmic phenomena beyond our imagination. And then there's Mars, the next great frontier. For years, NASA has studied the red planet, sending rovers to analyze its surface, search for signs of past water, and determine whether it could support human life. The ultimate goal? Colonization. But just like the moon, Mars has its own share of mysteries. Strange formations that resemble artificial structures, unusual readings detected by rovers, and even what some claim are signs of microbial life buried beneath the Martian soil. Could Mars have once harbored life? And if so, did it die out naturally, or was something else responsible? NASA insists that its search for extraterrestrial life is still in its early stages. But with the rise of private space companies like SpaceX, Blue Origin, and others, the future of space travel is no longer solely in the hands of government agencies. A new space race is underway, one that is not just about exploration, but about commercialization, colonization, and even the possibility of mining asteroids for resources. What will this mean for humanity's future among the stars? As we continue our journey, we will explore not only NASA's past and present, but the hidden mysteries of space itself. From the enigma of black holes to the possibility of parallel universes, from UFO sightings to the unexplained signals detected from deep space, our quest for knowledge is far from over. The universe is vast. The questions are endless. And the adventure has only just begun. Following the groundbreaking achievements of the Apollo era and the early triumphs of robotic explorers, humanity's gaze shifted from the lunar surface to the boundless depths of the cosmos. As NASA's efforts expanded beyond our own solar system, the mysteries of the universe beckoned us with questions that defied simple answers. In this new era of exploration, advanced space telescopes, deep space probes, and ambitious interplanetary missions opened an unprecedented window into the vast, uncharted territories of the universe. One of the most revolutionary developments came with the launch of the Hubble Space Telescope in 1990. Orbiting above the interference of Earth's atmosphere, Hubble provided crystal-clear images of distant galaxies, nebulae, and star clusters, reshaping our understanding of cosmic history. With its extraordinary capabilities, astronomers witnessed the birth and death of stars, observed galaxies colliding and merging, and peered back in time to see light that had traveled billions of years to reach us. Hubble's discoveries challenged our preconceptions, revealing a universe that was dynamic, ever-changing, and far more intricate than we had ever imagined. As Hubble unveiled the beauty of the cosmos, NASA continued to push the boundaries with ambitious missions that ventured further than ever before. The Voyager probes, launched in 1977, had already begun their historic journey, leaving our solar system and entering interstellar space. Their golden records, time capsules containing sounds, images, and greetings from Earth, served as a reminder that humanity's story was meant to be shared with the cosmos. Now, with new technology and a fresh sense of purpose, NASA planned even more daring missions. Projects like the James Webb Space Telescope, set to succeed Hubble, promise to extend our vision deeper into space and further back in time, unlocking secrets of the early universe and possibly providing clues about the formation of the very first stars and galaxies. Meanwhile, on the frontier of planetary exploration, Mars emerged as the next great challenge. Over the decades, NASA's rovers, Sojourner, Spirit, Opportunity, Curiosity, and Perseverance, transformed our view of the Red Planet. These robotic explorers traverse Martian terrain, analyzing rocks, drilling into ancient soils, and searching for signs of water and, possibly, past life. Their findings revealed a world that was once warmer and wetter, hinting that Mars might have harbored life long before it became the barren landscape we see today. The prospect of human missions to Mars grew ever more tangible, with plans to send astronauts to its surface in the coming decades. The dream of establishing a permanent human presence on another planet ignited imaginations worldwide and raised profound questions about our destiny among the stars. Yet, the quest for knowledge did not stop at our planetary neighbors. The discovery of thousands of exoplanets, worlds orbiting stars beyond our own sun, expanded the horizon of possibility. With the aid of powerful space-based observatories like Kepler and TESS, astronomers catalogued a diverse array of exoplanets, ranging from scorching gas giants to Earth-like rocky worlds. Some of these distant planets orbited within their star's habitable zone, where conditions might allow for liquid water and, by extension, life as we know it. The tantalizing possibility that we might one day find evidence of extraterrestrial life spurred both scientific inquiry and public fascination, driving debates over the existence of alien civilizations and the nature of life itself. The cosmos, however, is not just a serene expanse of twinkling stars and gentle nebulae. It also harbors phenomena of extraordinary violence and mystery. Black holes, regions of space-time where gravity is so intense that nothing, not even light, can escape, have long captivated scientists and the public alike. The study of black holes has led to profound insights into the nature of gravity and quantum mechanics. When two black holes collide, they create gravitational waves, ripples in the fabric of spacetime that were predicted by Einstein's theory of general relativity and first directly detected by LIGO in 2015. These discoveries opened a new window for observing the universe, allowing us to listen to cosmic events that were previously undetectable. At the same time, the enigmatic dark matter and dark energy that permeate the universe remain among the greatest puzzles in modern science. Although dark matter does not emit, absorb, or reflect light, its gravitational effects are unmistakable, holding galaxies together and influencing the large-scale structure of the cosmos. Dark energy, on the other hand, appears to be driving the accelerated expansion of the universe, a discovery that has upended our understanding of cosmic evolution. NASA and other space agencies continue to invest in missions and experiments aimed at unraveling these mysteries, aware that solving them could revolutionize our grasp of the fundamental laws that govern the universe. Beyond the scientific endeavors, the narrative of space travel has also inspired a rich tapestry of human creativity and philosophical reflection. The profound realization that Earth is but a tiny speck in a vast, indifferent universe has reshaped our perspectives on life, our responsibilities to our planet, and our place in the cosmos. This cosmic perspective, often called the overview effect by astronauts, has a way of uniting humanity, transcending national and cultural divides. As we venture further into space, the shared wonder of exploring the unknown serves as a reminder that our destiny is intertwined with the universe itself. Amidst these advancements, NASA continues to push for a future where space is accessible to all. Collaborations with private companies such as SpaceX and Blue Origin have accelerated technological innovations, lowering the cost of space travel and laying the groundwork for the commercialization of space. With ambitious plans for lunar bases, Mars colonization, and even asteroid mining, the era of interplanetary commerce may soon become a reality. Yet, each step forward brings with it a host of challenges, from ensuring astronauts' safety in the harsh conditions of space to addressing the ethical and environmental implications of exploiting extraterrestrial resources. In this new age of exploration, the mysteries of the cosmos and the promise of space travel offer both inspiration and responsibility. As we chart our path among the stars, we are called to consider not only the scientific and economic opportunities that lie ahead but also the profound questions of existence, purpose, and our legacy as a species. Every discovery, every mission, and every technological breakthrough builds upon the legacy of those early pioneers who dared to dream of a universe beyond the confines of Earth. The journey into the cosmos is a story of wonder, ambition, and relentless curiosity, a story that continues to unfold with each passing day. And while the road ahead is filled with challenges, the promise of unraveling the secrets of the universe and the hope of forging a brighter future among the stars remains as compelling as ever. As humanity gazes beyond our solar system, the quest to uncover the secrets of the cosmos continues to drive scientific discovery and technological innovation. We have always wondered whether we are alone in the universe, and as our tools of exploration become more sophisticated, we inch closer to answering that profound question. From radio telescopes scanning the heavens for alien signals to robotic probes venturing into the most extreme environments, the search for life beyond Earth has become one of the most compelling pursuits in modern astronomy. One of the most promising targets in our own celestial backyard is Europa, a moon of Jupiter. Beneath its thick icy shell lies a vast ocean, possibly containing more liquid water than all of Earth's oceans combined. Scientists believe that where there is water, there may be life. NASA's upcoming Europa Clipper mission aims to explore this possibility, mapping the moon's surface and analyzing plumes of water vapor that erupt from its cracks. If microbial life exists in the hidden depths of Europa's ocean, it could provide the first concrete evidence that life is not unique to Earth. But Europa is not the only world of interest. Saturn's moon Enceladus also possesses a subsurface ocean, with geysers blasting organic-rich material into space. These plumes have already been sampled by the Cassini spacecraft, revealing complex organic molecules, one of the building blocks of life. The presence of these ingredients, combined with the possibility of hydrothermal vents on the ocean floor, suggests that Enceladus may be one of the most habitable places in our solar system. Future missions may drill through its icy crust, searching for microbial life hiding in the deep. Beyond our solar system, the search for life takes an even more ambitious turn. Astronomers have identified thousands of exoplanets orbiting distant stars, some of which lie in the so-called habitable zone, the region where conditions may allow for liquid water. Planets like Proxima Centauri b, located just 4.2 light-years away, and the intriguing TRAPPIST-1 system, with multiple Earth-sized worlds, have sparked immense interest. With the James Webb Space Telescope now operational, scientists are analyzing the atmospheres of these planets, looking for biosignatures, chemical markers that could indicate life. If we were to detect oxygen, methane, or other gases in an exoplanet's atmosphere in a pattern that suggests biological activity, it would revolutionize our understanding of life's presence in the universe. But the search for life extends beyond merely identifying habitable worlds. Scientists at SETI, the Search for Extraterrestrial Intelligence, have spent decades scanning the skies for radio signals from alien civilizations. While no confirmed signals have been detected, intriguing anomalies have occasionally emerged, such as the famous WOW signal in 1977, a strong, unexplained radio burst that lasted 72 seconds. Advances in artificial intelligence and machine learning now allow astronomers to comb through vast amounts of data more efficiently, increasing our chances of detecting a genuine extraterrestrial signal. As we look outward, we also prepare for a future where humanity itself might become an interstellar civilization. The concept of interstellar travel has long been the domain of science fiction, but recent breakthroughs in physics and engineering suggest that such a future may not be as far-fetched as once thought. Theoretical propulsion systems, such as light sails powered by lasers or nuclear fusion engines, could one day allow us to reach neighboring star systems within a human lifetime. One of the most ambitious proposals comes from the Breakthrough Starshot initiative, which envisions tiny spacecraft, no larger than a microchip, attached to ultra-thin sails. These sails would be propelled by powerful laser beams fired from Earth, accelerating them to speeds approaching 20% of the speed of light. At such speeds, these probes could reach Proxima Centauri b in just over 20 years, sending back images and data from an alien world. But for humanity to truly embark on interstellar journeys, we must first master long-duration space travel. Establishing a permanent presence on the Moon and Mars is seen as the first step toward this goal. NASA's Artemis program aims to return humans to the Moon and create a sustainable lunar base, serving as a testing ground for technologies that will eventually take us to Mars. SpaceX's Starship, designed for deep space missions, could carry humans to Mars within the next decade, paving the way for the first extraterrestrial colony. Yet, as we stand on the precipice of becoming a multiplanetary species, we must confront the ethical and philosophical implications of space exploration. If we discover alien life, how should we interact with it? Should we protect pristine extraterrestrial environments from human interference? As we expand into the cosmos, these questions will shape the way we explore and settle new worlds. Humanity's journey into space is not just a scientific endeavor, it is a reflection of our deep-seated desire to push beyond boundaries, to explore the unknown, and to seek answers to the most profound questions about existence. Every step forward brings us closer to understanding our place in the vast and mysterious universe. The cosmos has always been a place of wonder, an infinite frontier that calls to us with its mysteries and possibilities. As we stand on the precipice of a new era in space exploration, the next great challenge is not just reaching the farthest corners of our solar system, but venturing beyond, to the distant stars, the exoplanets that may harbor life, and the uncharted realms of deep space. However, the vast distances and harsh conditions of interstellar travel present challenges that require breakthroughs in physics, engineering, and human endurance. Our first major stepping stone in this journey is the Moon. NASA's Artemis program is laying the groundwork for a long-term lunar presence, with the goal of establishing a sustainable base that will serve as a launching point for Mars and beyond. Unlike the Apollo missions, which were brief visits, Artemis envisions a future where humans will live and work on the Moon for extended periods, testing technologies that will one day be used for deep space travel. Lunar ice deposits at the Moon's south pole could provide water, oxygen, and even fuel for rockets, making space travel more self-sufficient and less dependent on Earth's resources. But the real test of our ability to survive in deep space will come with the first human missions to Mars. Unlike the Moon, which is only 3 days away, Mars is an unforgiving world, with a minimum journey time of 6 to 9 months. The thin atmosphere offers little protection from radiation, the temperatures can drop to extremes, and the lack of liquid water presents serious survival challenges. Yet, despite these obstacles, Mars represents the next logical step in humanity's journey. Scientists believe that with the right infrastructure, Mars could support a human settlement and one day even be terraformed to create a more Earth-like environment. Elon Musk's SpaceX has been at the forefront of Mars exploration plans, developing the massive Starship rocket designed to transport large numbers of people and cargo to the Red Planet. Starship, with its fully reusable design and powerful engines, could dramatically reduce the cost of space travel and make interplanetary colonization a reality. Other private space companies, such as Blue Origin, have their own visions for space expansion, competing to push the boundaries of technology and human capability. But Mars is just the beginning. Beyond our solar system lies a universe teeming with possibilities, countless exoplanets, cosmic phenomena that defy comprehension, and the tantalizing potential of discovering extraterrestrial life. The problem, however, is distance. Even the closest star system, Alpha Centauri, is over 4 light-years away. With current technology, it would take tens of thousands of years to get there. To overcome these immense distances, scientists are exploring revolutionary propulsion systems. One of the most promising concepts is nuclear propulsion, which could cut travel time to Mars in half and one day enable journeys to the outer planets and beyond. The concept of nuclear thermal propulsion, which uses a reactor to heat a propellant like hydrogen, has been in development for decades and could be tested in space within the next decade. Even more ambitious is nuclear fusion propulsion, which could generate far greater speeds, allowing for interstellar travel within a human lifetime. But perhaps the most revolutionary idea comes from the realm of theoretical physics. Scientists have long speculated about the possibility of warp drives, propulsion systems that could bend space-time itself, allowing a spacecraft to effectively jump from one point in the universe to another. Inspired by Einstein's theory of relativity, researchers like Miguel Alcubierre have proposed models where space could be compressed in front of a spacecraft and expanded behind it, enabling faster-than-light travel without violating the known laws of physics. While such technology remains purely theoretical, advancements in quantum mechanics and energy manipulation may one day make it feasible. Another intriguing possibility is the use of antimatter propulsion. Antimatter, the mirror opposite of regular matter, releases enormous amounts of energy when it comes into contact with normal particles. A spacecraft powered by antimatter could, in theory, reach a significant fraction of the speed of light. However, producing and storing antimatter in the quantities needed for space travel remains a major challenge, as even a single gram of antimatter would cost trillions of dollars to create with current technology. Beyond propulsion, deep space travel also presents biological and psychological challenges. The human body is not designed for the weightlessness and radiation exposure of space, and long-duration missions could lead to muscle atrophy, bone loss, and increased cancer risks. Even more concerning are the psychological effects: prolonged isolation, the vast emptiness of space, and the knowledge that home is millions of miles away could take a serious toll on astronauts. Future missions will need advanced medical technologies, artificial gravity solutions, and possibly even hibernation systems similar to those seen in science fiction. As we move closer to the reality of deep space travel, ethical questions also come into play. If we discover life beyond Earth, how should we interact with it? Should we avoid contaminating other worlds with Earth-based microbes? Should we attempt to communicate with intelligent extraterrestrial civilizations if we find them? Some scientists warn that broadcasting our presence to the cosmos could be risky. If advanced alien species exist, their intentions toward us would be unknown. The famous physicist Stephen Hawking cautioned that contacting extraterrestrial life could be dangerous, drawing a parallel to how technologically advanced civilizations have historically treated less developed ones here on Earth. Yet, despite these risks, the hunger for exploration persists. Throughout history, every great leap forward has come with challenges, doubts, and dangers. But the human spirit has always been driven to explore, to push beyond the limits of what is known, and to seek answers to the greatest mysteries of existence. As we look to the stars, we must also remember that space exploration is not just about scientific progress, it is about the survival of our species. Earth, for all its beauty, is vulnerable. Natural disasters, climate change, and even the threat of asteroid impacts remind us that staying confined to a single planet is a risk in itself. Expanding into space could ensure the long-term survival of humanity, giving us the ability to adapt and thrive in new environments, no matter what challenges the future may bring. The journey into the cosmos is only beginning. With each new mission, each new discovery, we take another step forward. The questions that drive us: are we alone? How did the universe begin? What lies beyond the edges of our understanding are the same questions that have fueled human curiosity for centuries. And as we continue to push the boundaries of science and technology, the answers may be closer than we ever imagined. As humanity takes its first steps beyond Earth, a new frontier emerges, one that is both thrilling and overwhelming. The cosmos, an endless expanse stretching in all directions, is a vast and silent ocean filled with enigmas we have only begun to decipher. The deeper we look, the more we realize how little we know. What lies beyond the furthest reaches of our telescopes? How did the universe come to be, and what is its ultimate fate? Could there be other civilizations, perhaps ancient, advanced, or even watching us at this very moment? One of the most perplexing questions in astronomy is the nature of dark matter and dark energy. These unseen forces shape the universe, yet they remain elusive, detectable only through their effects on galaxies and cosmic expansion. Scientists estimate that ordinary matter, the kind that makes up stars, planets, and everything we see, accounts for only 5% of the universe. The remaining 95% consists of dark matter and dark energy, mysterious substances that do not emit, absorb, or reflect light. Dark matter acts like an invisible web, holding galaxies together with a gravitational pull that cannot be explained by visible matter alone. Without it, galaxies would fly apart, unable to maintain their structure. Despite decades of research, no direct evidence of dark matter particles has been found. Some theories suggest that it could be composed of exotic particles yet to be discovered, or even be the result of undiscovered laws of physics. Even more perplexing is dark energy. In the late 1990s, astronomers discovered that the universe's expansion is accelerating, a shocking revelation that defied previous expectations. Rather than slowing down due to gravity, the universe is stretching faster and faster. The force responsible for this acceleration is known as dark energy, and it makes up nearly 70% of the cosmos. What is it? Some scientists believe it may be an unknown form of energy inherent to space itself, while others speculate that it could be a sign of hidden dimensions or even a multiverse. As we attempt to understand the universe's structure, we also grapple with its origins. The prevailing theory, the Big Bang, suggests that everything we see today was once compressed into an infinitely small, dense singularity. About 13.8 billion years ago, this singularity erupted, expanding rapidly in an event that created space, time, and matter. But what came before the Big Bang? And will the universe last forever? These questions remain open, with competing theories offering different possibilities. Some suggest that the universe will continue expanding indefinitely until all stars burn out, leaving behind a cold and lifeless void. Others propose that cosmic expansion will reverse, leading to a catastrophic Big Crunch where the universe collapses back into a singularity. Another theory, known as the Big Bounce, suggests that our universe is just one in a cycle of endless expansions and contractions. These mysteries drive scientists to push the limits of observation, using advanced telescopes like the James Webb Space Telescope, which peers deeper into the past than any instrument before it. Every photon of light it captures has traveled billions of years to reach us, revealing ancient galaxies that existed when the universe was young. By studying them, we piece together the story of how stars, planets, and life itself came to be. But while we search for answers about our past, we also look ahead to the future of space travel and the possibility of becoming an interstellar species. The dream of colonizing other planets is no longer just science fiction. With technological advances, we may soon establish permanent human settlements beyond Earth. Terraforming, a concept once confined to the realm of imagination, may become a necessity if we are to survive in the harsh environments of space. Mars, the most Earth-like planet in our solar system, has been proposed as humanity's first interplanetary home. Though its atmosphere is thin and its surface barren, it contains the raw materials needed to sustain life. Scientists have proposed using massive mirrors to focus sunlight on Mars, warming the planet and releasing trapped carbon dioxide to create a thicker atmosphere. Others suggest introducing genetically modified microbes to produce oxygen or even detonating nuclear explosions at the poles to release water vapor. But the challenges of interplanetary survival go beyond just transforming the landscape. Humans on Mars or any other world would need to adapt to lower gravity, higher radiation exposure, and the psychological toll of isolation. Even communication would be delayed. Messages sent between Earth and Mars would take anywhere from 5 to 20 minutes to arrive, making real-time conversations impossible. If an emergency occurred, help would be months, if not years, away. Looking beyond our solar system, we must consider what it would take to reach the stars. Could humans one day travel to Proxima Centauri b, the nearest potentially habitable exoplanet, located just over 4 light-years away? With current technology, such a journey would take thousands of years, but future advancements might change that. One proposed method is generation ships, massive spacecraft designed to carry entire human civilizations for centuries or even millennia, with successive generations living and dying aboard the vessel until their distant descendants finally reach a new home. While such a concept could allow humanity to spread across the galaxy, ethical dilemmas arise. Would those born on the ship have a choice in their destiny? Could a society remain stable over such long periods? Another possibility is cryogenic sleep, inspired by the hibernation cycles of certain animals on Earth. If astronauts could be placed in a state of suspended animation, they might endure long space journeys with minimal resource consumption. Although currently beyond our capabilities, experiments on deep cooling human organs without damage are already underway. For even greater distances, we may need to consider digital consciousness transfer, the idea of uploading human minds into advanced computers and sending them as data across space. Such a method could bypass the physical limitations of space travel, allowing intelligence to spread across the galaxy without the need for biological bodies. While still purely theoretical, rapid advances in neuroscience and artificial intelligence may one day make such a concept a reality. As we develop these technologies, we must also consider our role in the universe. Are we truly alone, or are other civilizations also reaching for the stars? The Fermi paradox raises a haunting question: if intelligent alien life is statistically likely, why have we not yet found any evidence of it? Some speculate that advanced civilizations may be deliberately avoiding us, while others believe that life is far rarer than we assume. There is also the unsettling theory of the Great Filter, the idea that somewhere along the path from primitive life to interstellar travel, there exists a nearly insurmountable barrier that prevents civilizations from surviving. If true, the question remains, have we already passed this filter, or is it still ahead of us? The mysteries of the cosmos are endless, and every answer we uncover seems to raise more questions. Yet, despite the vastness of space and the seemingly impossible odds, we continue to explore, to innovate, and to dream. The future of space travel is uncertain, but one thing is clear: our journey is only beginning. For centuries, humanity has looked up at the night sky and wondered what lies beyond. From the first crude telescopes to the cutting-edge instruments of today, our view of the cosmos has expanded, but so too have the questions. The deeper we probe into space, the more mysteries emerge. With every new discovery, we come closer to understanding our place in the universe, yet at the same time, we realize how little we truly know. Space is a realm of extremes. It is a place where temperatures can drop hundreds of degrees below freezing or rise to scorching levels in the absence of an atmosphere. It is a vacuum where no air exists to carry sound, where radiation from distant stars bombards any unprotected body, and where distances are so vast that time itself seems to stretch and warp. Surviving in such an environment requires technology beyond anything we have ever created on Earth. And yet, despite the dangers, humanity continues to push outward. One of the greatest challenges of space travel is propulsion. The rockets we use today, powerful as they are, remain inefficient for long-distance travel. Chemical propulsion, which relies on burning fuel to generate thrust, is effective for escaping Earth's gravity, but it is not practical for interstellar journeys. A spacecraft traveling with current technology would take over 73,000 years to reach Proxima Centauri, our closest neighboring star. To go beyond our solar system, we need a revolution in propulsion technology, one that could take us to the stars within a human lifetime. Several potential solutions exist, each with its own set of challenges. One possibility is nuclear propulsion, which could use the energy from fission or fusion reactions to accelerate a spacecraft to much higher speeds than traditional rockets. Nuclear thermal propulsion, for example, could cut the travel time to Mars in half, while more advanced designs, such as nuclear pulse propulsion, could theoretically reach speeds that would allow us to explore the outer solar system in a matter of months instead of decades. Another promising technology is ion propulsion, which uses electrically charged particles, or ions, to generate thrust. Though weak compared to chemical rockets, ion engines are incredibly efficient and can operate for months or even years without running out of fuel. NASA's Dawn spacecraft, which explored the asteroid belt, used an ion engine to travel between celestial bodies, proving the feasibility of long-duration space travel with minimal fuel consumption. But to truly reach the stars, we may need something even more advanced: light sail technology. This concept, inspired by the way a sailboat catches the wind, involves using large, ultra-thin sails to capture photons from a powerful laser or the sun itself. The continuous pressure from light could, over time, accelerate a spacecraft to speeds approaching a significant fraction of the speed of light. Projects like Breakthrough Starshot have proposed using laser-driven sails to send tiny probes to Proxima Centauri in just 20 years, providing our first real glimpse of another solar system. If propulsion challenges can be overcome, the next issue is survival. Space is an unforgiving environment. Beyond Earth's protective magnetic field, astronauts are exposed to intense radiation from cosmic rays and solar flares, which can damage DNA and increase the risk of cancer. Future missions to Mars and beyond will require new shielding methods, possibly involving water barriers, magnetic fields, or even genetically engineered resistance to radiation. There is also the issue of microgravity. On Earth, our bodies have evolved to function under the constant pull of gravity, but in space, prolonged weightlessness leads to muscle atrophy, bone density loss, and changes in fluid distribution that can affect vision and cardiovascular health. Current solutions include rigorous exercise routines and medications, but long-term missions may require artificial gravity, perhaps by spinning spacecraft to create centrifugal force, mimicking the effects of gravity. Then there is the question of mental health. Isolation, confinement, and the psychological strain of being millions of kilometers from home can take a toll on even the most resilient astronauts. NASA and other space agencies have conducted extensive research on how to maintain crew morale on long missions, exploring solutions such as virtual reality environments, carefully planned social interactions, and AI companions to provide emotional support. Even if we solve these problems, there is another, more profound challenge: what happens when we find life? For decades, we have searched the cosmos for signs of extraterrestrial intelligence. Radio telescopes have scanned the sky for signals, robotic probes have explored distant worlds, and scientists have examined exoplanets for atmospheres rich in biosignatures. Yet, so far, we have found nothing. This absence of evidence presents a paradox. Given the vastness of the universe, life should be common, but where is it? Some theories suggest that life may be incredibly rare, requiring a perfect combination of conditions that are seldom met. Others propose that alien civilizations may be avoiding us, perhaps deliberately staying silent to protect themselves. More unsettling is the idea that civilizations tend to destroy themselves before they ever reach the stage of interstellar expansion, a possibility known as the Great Filter. But what if the reason we haven't found life is because we're looking in the wrong way? Some scientists argue that advanced extraterrestrial civilizations might not use radio signals or other detectable means of communication. Instead, they could exist as post-biological entities, having transferred their consciousness into digital forms, or they might manipulate the very fabric of space and time in ways we cannot yet comprehend. If we do find life, whether microbial organisms beneath the icy crust of Europa or an intelligent civilization among the stars, it would be the most profound discovery in human history. The implications would be enormous, forcing us to rethink our place in the cosmos, our philosophies, our religions, and our understanding of life itself. For now, we continue our search, sending out signals, launching telescopes, and preparing for the day when the silence of the cosmos is finally broken. As we stand at the dawn of a new era in space exploration, we must ask ourselves, are we ready for what we might find? And if we do encounter another form of life, will we be the explorers, or will we be the ones discovered? The universe is vast, mysterious, and full of possibilities. Every star in the sky is a potential home, a world waiting to be explored. And as humanity takes its first steps beyond Earth, we are not just searching for answers, we are searching for our future. As we continue our journey into the cosmos, a profound question emerges: can humanity survive beyond Earth? For millennia, our planet has been our only home. It has given us air to breathe, water to drink, and a protective atmosphere shielding us from the cold, harsh void of space. But Earth is not invulnerable. Natural disasters, asteroid impacts, climate change, and even the eventual death of our sun all pose existential threats to humanity's long-term survival. If we wish to endure as a species, we must look beyond our home world and become a multiplanetary civilization. The idea of colonizing other planets has long been a topic of science fiction, but in recent years, it has become a serious scientific and engineering challenge. The most immediate and realistic target for colonization is Mars. As the fourth planet from the Sun, Mars has long captured the human imagination. It is the only planet in our solar system that, despite its harsh conditions, offers a remote possibility of supporting life either in its past or in its future. But why Mars? Why not Venus or one of the moons of Jupiter or Saturn? The answer lies in its unique characteristics. Mars has a day length similar to Earth's, lasting about 24.6 hours. This means that human circadian rhythms would not need to be drastically altered, unlike life on the Moon, where day and night cycles last 2 weeks each. Mars also has polar ice caps, underground water deposits, and seasonal weather patterns that suggest it could one day sustain life with the right technology. However, the challenges are immense. Mars has a thin atmosphere composed mostly of carbon dioxide, meaning there is almost no breathable air. Its average surface temperature is -63 degrees Celsius -81 degrees Fahrenheit, far colder than any place on Earth. Worse still, the low atmospheric pressure would cause human blood to boil if exposed without a pressurized suit. Radiation levels on the surface are much higher than on Earth, due to the lack of a protective magnetic field. Despite these obstacles, scientists and engineers are already working on solutions to make Mars habitable. One approach involves the concept of terraforming, altering an entire planet's environment to make it more Earth-like. Theoretically, this could be achieved by releasing greenhouse gases, such as carbon dioxide, to warm the planet and create a thicker atmosphere. Large mirrors in orbit could reflect sunlight onto the surface, increasing temperatures. Some scientists even propose redirecting asteroids to impact the planet, releasing water and essential minerals. But terraforming is a long-term goal, one that would take centuries, if not millennia. In the short term, survival on Mars would depend on enclosed, self-sustaining habitats, capable of recycling air, water, and food. These structures would need to be heavily shielded against radiation and designed to withstand dust storms that can engulf the entire planet for weeks at a time. Several space agencies and private companies are already working toward this goal. NASA plans to send humans to Mars in the 2030s, while SpaceX, led by Elon Musk, has outlined an ambitious vision to establish a permanent colony. The company's Starship spacecraft is being designed to carry dozens of people at a time, with the ultimate goal of building cities on the red planet. Musk's vision is clear: if we make life multiplanetary, we ensure the survival of consciousness as we know it. But Mars is not the only option. Beyond Mars, the moons of the gas giants offer potential habitats for human exploration. Europa, a moon of Jupiter, is covered in ice, but beneath its frozen surface lies a vast ocean, one that may harbor extraterrestrial life. Some scientists believe that, with the right technology, Europa's subsurface ocean could support an underwater colony, protected from radiation by thick layers of ice. Titan, Saturn's largest moon, presents another intriguing possibility. Unlike Mars, Titan has a thick atmosphere composed mostly of nitrogen, making it the only moon in the solar system with an atmosphere substantial enough to support human activity. Though it is extremely cold, with temperatures around -180 degrees Celsius -292 degrees Fahrenheit, its dense atmosphere means that humans could theoretically walk on the surface with only a breathing apparatus, rather than a full pressurized spacesuit. Titan also has lakes and rivers, not of water but of liquid methane and ethane. While deadly to humans, these hydrocarbons could potentially be used as a source of fuel, making Titan a self-sustaining outpost for deeper space travel. Of course, these destinations are still far beyond our current capabilities. Even getting to Mars is a monumental challenge, requiring months of travel through the radiation-filled void of space. Long-duration spaceflight presents numerous physiological and psychological challenges, from bone and muscle deterioration to mental strain caused by isolation and confinement. To overcome these difficulties, scientists are exploring new forms of hibernation technology, inspired by animals that enter a state of torpor during the winter. If astronauts could be placed into a form of suspended animation, similar to deep sleep, it could reduce the need for food, water, and psychological support during long journeys. NASA and ESA have already begun experiments in this field, testing whether inducing hibernation could be a viable way to reach distant worlds. But perhaps the most promising solution for deep space colonization is the concept of space habitats, massive, rotating space stations capable of housing thousands of people. Instead of settling on planets, these megastructures could provide artificial gravity through rotation, ensuring a stable environment free from the hazards of planetary weather or weak magnetic fields. Concepts such as O'Neill cylinders, proposed by physicist Gerard K. O'Neill, envision enormous cylindrical colonies where humans could live, work, and even farm, creating a self-sufficient society drifting between the stars. If such habitats can be built, it raises an even greater question: do we even need planets? For now, humanity's reach is still limited. But as our technology advances, as our ambition grows, we will inevitably take the next step in our cosmic journey. The transition from a single-planet species to a spacefaring civilization is the most important leap we will ever take, one that will define our future for millennia to come. Because in the vast emptiness of space, there is one undeniable truth: our survival depends on expansion. We are explorers. We are pioneers. And as long as the stars shine in the night sky, we will keep moving forward, toward the unknown, toward discovery, and toward our destiny among the stars. Are we alone in the universe? For as long as humans have gazed up at the night sky, we have wondered whether other forms of life exist beyond Earth. In ancient times, civilizations looked to the heavens and imagined gods, spirits, or celestial beings watching over them. Today, with the tools of modern science, we search not for myths, but for biological signs, evidence that life, in some form, exists elsewhere in the cosmos. But where do we begin such a search? The most obvious place to start is within our own solar system. While Earth is the only known planet teeming with life, there are several other worlds that might have once been, or still could be, home to living organisms. Mars, our closest planetary neighbor, has been at the center of this search for decades. In 1976, NASA's Viking landers conducted the first life detection experiments on Martian soil. While their results were inconclusive, the discovery of seasonal methane emissions on Mars has kept the possibility of microbial life alive. Methane can be produced by geological processes, but on Earth, most methane is created by living organisms. Could the same be true for Mars? If life does exist there, it is likely buried beneath the surface, protected from harsh radiation by layers of rock and dust. Beyond Mars, Europa, one of Jupiter's largest moons, is another prime candidate for life. Beneath its thick icy crust lies a vast, liquid ocean, one that contains more water than all of Earth's oceans combined. Scientists believe that deep-sea hydrothermal vents on Europa's ocean floor could provide the necessary energy and nutrients for life, much like similar vents on Earth sustain thriving ecosystems in total darkness. NASA's upcoming Europa Clipper mission aims to investigate these possibilities by flying close to the Moon and analyzing its icy plumes for organic compounds. Enceladus, a moon of Saturn, presents a similar mystery. It, too, has a subsurface ocean, and it has been observed shooting massive jets of water vapor into space. When NASA's Cassini spacecraft passed through one of these plumes, it detected complex organic molecules, the building blocks of life. If life exists in Enceladus's ocean, it could be microbial, thriving in deep, dark waters beneath miles of ice. But what if life exists not just within our solar system, but far beyond it? Astronomers have now identified thousands of exoplanets, planets orbiting stars outside our solar system. Some of these exoplanets exist in the habitable zone of their stars, where temperatures are just right for liquid water to exist. Among them is Proxima Centauri b, an Earth-sized planet orbiting the closest star to our Sun. While little is known about its atmosphere, some scientists speculate that it could have conditions suitable for life. The discovery of exoplanets has sparked new efforts to find extraterrestrial life, particularly through biosignatures, chemical clues in a planet's atmosphere that may indicate biological activity. Oxygen, methane, and water vapor are among the key signs scientists look for. NASA's James Webb Space Telescope, JWST, launched in 2021, is now analyzing the atmospheres of distant exoplanets with unprecedented detail, searching for any hint of life. Yet, the search for extraterrestrial life goes beyond biology. Some researchers believe that if life exists elsewhere in the universe, it might have evolved to the point of intelligence, technology, and even spacefaring capabilities. This brings us to the search for extraterrestrial intelligence, SETI, a field dedicated to detecting signals from alien civilizations. For decades, scientists have used powerful radio telescopes to scan the skies for unusual signals that might indicate an advanced extraterrestrial society trying to communicate. In 1977, the WOW signal, a strong, unexplained radio burst, was detected by the Big Ear Radio Telescope. While it has never been repeated, it remains one of the most intriguing signals ever recorded. Was it a message from an alien civilization? Or just an unexplained cosmic phenomenon? More recently, SETI has expanded its efforts with advanced algorithms and artificial intelligence, sifting through vast amounts of data for patterns that cannot be explained by natural sources. The hope is that one day, we will intercept a clear, undeniable message from an alien intelligence, one that could change human history forever. But what if extraterrestrial civilizations are already aware of us? Some scientists believe that if intelligent life exists, it may have visited Earth in the distant past. This idea, known as the ancient astronaut theory, suggests that myths of gods descending from the sky could be distorted memories of alien visitors. While mainstream science remains skeptical, certain historical mysteries, such as the Great Pyramid of Giza, the Nazca Lines of Peru, and ancient texts describing celestial beings, continue to fuel speculation. There is also the unsettling possibility that aliens are deliberately avoiding us. This concept, known as the Great Silence, or the Fermi paradox, raises a troubling question: if intelligent life is common in the universe, why haven't we found any evidence of it? Several theories attempt to answer this. One possibility is that civilizations inevitably destroy themselves before they can become interstellar. War, climate change, or uncontrolled artificial intelligence could wipe out intelligent species before they have a chance to expand into the cosmos. Another theory is that advanced extraterrestrial civilizations exist but deliberately avoid contact with us, perhaps viewing Earth as a primitive world that is not yet ready for interstellar diplomacy. Some compare this idea to how humans observe wild animals, choosing not to interfere with their natural development. Yet another chilling possibility is that the universe is not a friendly place. Perhaps intelligent civilizations exist, but they remain silent to avoid attracting attention from more powerful, possibly hostile beings. In this scenario, the reason we haven't detected extraterrestrial life is that the smartest civilizations know not to broadcast their presence. Regardless of the answer, one thing is certain: the search for extraterrestrial life is one of the most profound and exciting scientific pursuits of our time. If life is discovered beyond Earth, whether in the form of ancient microbes on Mars, alien fish beneath Europa's ice, or a distant civilization broadcasting signals across the stars, it would forever change our understanding of the universe and our place within it. Because in the end, the question is not just whether extraterrestrial life exists, but whether we are ready to meet it. As we continue our journey through the cosmos, we cannot overlook the profound impact that space exploration has had on human knowledge and society. While the search for extraterrestrial life is undoubtedly a driving force, there is another equally important aspect to our journey into space: understanding our place in the universe. Space exploration has transformed our understanding of physics, astronomy, and even the origins of life itself. And perhaps more importantly, it has opened our eyes to the vastness of space and the humbling reality of our existence within it. It's easy to take for granted the images of distant galaxies, swirling nebulae, and the delicate blue marble of Earth that we now regularly see in our media and everyday lives. These images are not just beautiful, they represent decades of human ingenuity, perseverance, and the relentless pursuit of knowledge. The journey to the stars began with a simple desire to understand the unknown, but along the way, it has sparked the development of technologies that have revolutionized every aspect of our lives. From communications to medicine, from computing to environmental monitoring, the technologies we've developed for space exploration have found countless applications here on Earth. At the heart of this quest is the space program, a global endeavor involving countless nations, organizations, and private companies. The modern space age began in 1957 when the Soviet Union launched Sputnik 1, the first artificial satellite to orbit Earth. This momentous event marked the beginning of the space race, a competition between the United States and the Soviet Union to establish dominance in space exploration. It ignited a wave of scientific and technological advancements, culminating in the most iconic moment in human history, the Apollo 11 mission, when Neil Armstrong and Buzz Aldrin became the first humans to walk on the Moon in 1969. But space exploration is far from limited to just the Moon. In the decades since, human spaceflight has expanded to include missions to other planets, the construction of the International Space Station, ISS, and the exploration of asteroids, comets, and distant moons. Each new milestone brings with it new discoveries, and with every mission, we expand our understanding of the universe. One of the most significant advancements in space exploration has been the development of space telescopes, instruments designed to observe the cosmos without the interference of Earth's atmosphere. Before the launch of telescopes like the Hubble Space Telescope in 1990, astronomers were limited to observing the universe through ground-based telescopes. These telescopes could only see a fraction of the light emitted by distant stars and galaxies because the Earth's atmosphere distorts and absorbs much of the light that comes from space. Hubble revolutionized our understanding of the universe, providing clearer and more detailed images of distant galaxies, nebulae, and planets. With its powerful cameras and spectrometers, Hubble has helped scientists measure the expansion of the universe, discover new planets and exoplanets, and even determine the age of the universe. Its observations have changed everything we thought we knew about space, from the way galaxies form to the nature of dark energy. The Hubble Space Telescope remains one of the most significant scientific instruments ever built and continues to send back valuable data to this day. However, as powerful as Hubble is, it is limited in its ability to observe the universe in certain wavelengths of light, such as infrared. This is where the James Webb Space Telescope, JWST, set to launch in the 2020s, will step in. JWST promises to be even more powerful, with the ability to observe the universe in the infrared spectrum, allowing us to look deeper into space and time than ever before. With its ability to detect faint light from the earliest galaxies, JWST has the potential to answer some of the most profound questions about the origins of the universe and the formation of stars, planets, and galaxies. But space exploration is not limited to observation alone. Over the past few decades, we've sent numerous robotic probes to the planets of our solar system, providing us with detailed pictures of their surfaces and atmospheres. Missions like Voyager 1 and Voyager 2, launched in 1977, have traveled farther than any other human-made object, carrying with them a golden record that serves as a message to any potential extraterrestrial civilizations they might encounter. These probes have sent back valuable information about the outer planets, including Jupiter's Great Red Spot, Saturn's rings, and the icy moons of Uranus and Neptune. Perhaps one of the most groundbreaking missions in recent years has been the exploration of Mars. For decades, Mars has been the subject of intense interest due to its potential to support life, both past and present. Robotic missions like Curiosity and Perseverance have landed on the Red Planet, sending back images and data that suggest Mars once had flowing water and may have been habitable in the distant past. The Perseverance rover, which landed in 2021, is particularly significant, as it is tasked with collecting soil samples that could one day be returned to Earth for further analysis. In addition to these robotic probes, there are plans to send humans to Mars in the coming decades. NASA's Artemis program, which aims to return astronauts to the Moon, is seen as a stepping stone toward eventual human exploration of Mars. The Mars mission will require overcoming significant technological and logistical challenges, including radiation protection, life support systems, and the ability to land on and take off from the Martian surface. But despite these obstacles, the desire to send humans to Mars remains strong, driven by the potential to discover whether life ever existed on the planet and to learn more about the broader history of the solar system. While robotic exploration has provided us with invaluable data, human spaceflight remains the ultimate frontier. Human presence in space offers an opportunity for direct exploration, allowing astronauts to conduct experiments, repair equipment, and make real-time decisions that would be impossible for robots to replicate. The International Space Station, ISS, which has been continuously inhabited since 2000, serves as a unique laboratory for scientific research in microgravity. Astronauts aboard the ISS conduct experiments in biology, physics, astronomy, and other fields, providing insights that cannot be obtained on Earth. Research conducted on the ISS has led to advancements in fields like medicine, materials science, and environmental monitoring, all of which benefit life on Earth. Moreover, the ISS is a testament to the power of international collaboration. The space station is a joint project involving NASA, Roscosmos, the European Space Agency, ESA, the Japan Aerospace Exploration Agency, JAXA, and the Canadian Space Agency, CSA. It serves as a symbol of what can be achieved when nations come together to pursue a common goal, and it provides a platform for continued collaboration in the future of space exploration. Looking ahead, space exploration is set to enter a new era, one marked by privatization and commercial space travel. Companies like SpaceX, Blue Origin, and Virgin Galactic are pushing the boundaries of space travel, developing rockets and spacecraft that could make space tourism and space colonization a reality within the next few decades. These advancements are lowering the cost of space access and opening up new possibilities for scientific research, industrial development, and even space-based tourism. In addition to their role in exploring other planets, these private companies are also developing space stations, moon bases, and interplanetary spacecraft that could take humanity farther into space than ever before. With the rapid pace of innovation, we are on the cusp of a future where space is no longer the domain of governments alone. In the coming decades, the opportunity to travel and even live in space may become a reality for more than just astronauts. The technological advancements that have enabled us to explore the cosmos are nothing short of miraculous. From rocket engines that defy gravity to the telescopes that reveal the farthest reaches of the universe, space exploration has shaped the course of human history in ways we never could have imagined. But beyond the technology lies the fundamental human drive to explore, to seek answers, and to understand the universe we call home. As we continue to look up at the stars, it is important to remember that space exploration is not just about reaching distant planets or searching for alien life. It is about pushing the boundaries of our knowledge, expanding our horizons, and ensuring that the story of humanity continues for generations to come. As we stand at the precipice of a new era in space exploration, it is clear that the future holds both incredible challenges and remarkable opportunities. In the coming decades, we will witness the unfolding of humanity's next chapter in the cosmos, one that promises to redefine our place in the universe and expand the boundaries of human potential. But before we can even begin to fathom the possibilities that lie ahead, we must consider the technological and societal challenges we must overcome. One of the foremost goals for the future of space exploration is the establishment of a permanent human presence beyond Earth. NASA's Artemis program, which aims to return astronauts to the Moon by the mid-2020s, serves as the foundation for this ambitious goal. The Artemis program is not merely about planting flags and collecting rocks, it's about creating a sustainable presence on the Moon that will serve as a launching point for future missions to Mars and beyond. By developing the necessary infrastructure on the Moon, habitats, resource extraction methods, and in-situ production capabilities, we will be able to extend humanity's reach into deep space, making the dream of interplanetary exploration a reality. The Moon, once considered a lifeless rock orbiting Earth, has revealed itself to be far more than that. Beneath its surface, scientists have discovered vast deposits of water ice, particularly at the lunar poles. This discovery is a game-changer for future space missions. Water is essential not just for sustaining life but also for producing fuel. By extracting water from the Moon's surface, astronauts could potentially use electrolysis to separate the hydrogen and oxygen, creating rocket fuel that could be used to power future missions to Mars. This process, known as in-situ resource utilization (ISRU), will allow space exploration to become far more sustainable and cost-effective. NASA's Lunar Gateway, a space station that will orbit the Moon, will serve as a staging point for future missions to the lunar surface and beyond. It will provide a hub for astronauts to live and work, as well as a laboratory for scientific research in lunar orbit. This collaborative international effort will bring together space agencies and private companies, creating a platform for future advancements in space exploration. The Lunar Gateway is set to be an integral part of humanity's journey to becoming a multiplanetary species. But the Moon is only the beginning. Mars, the red planet, remains humanity's next great frontier. The prospect of sending humans to Mars has captivated our imaginations for decades, and with advancements in technology, it is no longer a far-off dream. Private companies like SpaceX are spearheading the charge to send the first crewed missions to Mars, with ambitious plans to establish self-sustaining colonies on the planet by the mid-21st century. SpaceX's Starship is central to this vision. This fully reusable spacecraft, designed to carry large numbers of passengers and cargo to the Moon, Mars, and beyond, promises to drastically reduce the cost of space travel. By lowering the cost of access to space, we can make interplanetary exploration a reality for humanity. But SpaceX isn't the only company pushing the boundaries of space travel. Blue Origin, founded by Amazon's Jeff Bezos, and Virgin Galactic, headed by Sir Richard Branson, are also working on spacecraft that could take civilians on suborbital flights into space, allowing the dream of space tourism to come true. These private companies are making it increasingly clear that space is no longer the exclusive domain of governments, it is becoming an industry in its own right, with the potential to reshape the global economy. One of the most exciting aspects of these endeavors is the possibility of space settlements. Just as humanity once built colonies on Earth, we may one day build colonies in space. Whether on the Moon, Mars, or even in artificial space stations, the prospect of living beyond Earth is becoming more plausible. But creating a permanent human presence in space will require overcoming significant obstacles, including radiation exposure, life support systems, and the ability to grow food and recycle water. Solutions to these challenges are already being developed in laboratories around the world, and with the right combination of technology, innovation, and international cooperation, space settlements could be a reality within this century. But while the technological challenges are daunting, the societal implications of space colonization are equally significant. As we look to the stars, we must consider the ethical questions surrounding the colonization of other planets. What does it mean for humanity to become an interplanetary species? Will we find alien life? And if we do, how will we interact with it? Will we have the wisdom and responsibility to act in harmony with other life forms, or will we repeat the mistakes of history and exploit the new worlds we encounter? Moreover, the societal impact of space exploration extends far beyond the technical challenges. It has the potential to transform our world in profound ways. The pursuit of space exploration has already sparked the development of numerous technologies that have improved life on Earth, from satellite communications to advanced materials, from climate monitoring to medical innovations. As we push forward into the cosmos, we will undoubtedly discover new technologies and ideas that will continue to enhance life here on Earth. Space exploration has the power to unite humanity in a common cause, transcending political boundaries and fostering a sense of global cooperation. One of the most important aspects of space exploration in the coming years will be the role of artificial intelligence, AI. AI is already transforming space missions, helping to analyze vast amounts of data, make autonomous decisions, and even assist with the operation of spacecraft. As missions become more complex and the distances involved grow larger, AI will become an essential tool for ensuring the success of missions to the Moon, Mars, and beyond. In addition, AI could play a role in terraforming, the process of altering the environment of a planet to make it more habitable for humans. While this concept is still in the realm of science fiction, the possibility of creating Earth-like conditions on another planet is one of the many exciting frontiers that space exploration holds. The future of space exploration will also rely heavily on international collaboration. The successes of the International Space Station, ISS, demonstrate the power of nations working together to achieve a common goal. As we look to the Moon, Mars, and other distant destinations, it is clear that space exploration will require the combined efforts of governments, private companies, and scientific institutions from around the world. By sharing resources, expertise, and knowledge, we can overcome the obstacles that stand in our way and ensure that space exploration remains a collaborative, rather than competitive, endeavor. As we continue to venture into the unknown reaches of space, we face monumental challenges that will test humanity's ingenuity, resilience, and determination. While space exploration holds immense promise, the journey ahead is far from easy. Every step forward is fraught with technical, physical, and logistical hurdles. The first of these challenges is the question of human survival in space. Space, by its very nature, is hostile to life. The vacuum of space provides no air to breathe, no warmth to keep us alive, and no protection from the harsh radiation that bombards us from the cosmos. For any long-duration mission, whether to the Moon, Mars, or beyond, astronauts will need to live and work in environments that simulate Earth's atmosphere. This means creating sealed habitats that provide life support systems, oxygen, temperature regulation, and protection from radiation. Radiation is one of the most significant threats that astronauts will face in space. On Earth, we are shielded from harmful cosmic radiation by our planet's atmosphere and magnetic field. But in space, particularly beyond Earth's protective bubble, astronauts are exposed to high levels of ionizing radiation that can cause serious health problems, including cancer and genetic damage. To mitigate this risk, space agencies are developing radiation shielding technologies that will help protect astronauts during long-duration missions. These technologies could involve physical shielding made of advanced materials or even utilizing the resources available on the Moon or Mars, such as regolith, to create protective walls for habitats. In addition to radiation, the isolation and psychological effects of space travel will play a major role in the success of future missions. As we venture farther from Earth, astronauts will experience extended periods of isolation, separated from family and friends by vast distances. The psychological toll of such isolation can be profound. Long missions to Mars, for instance, could take anywhere from 6 to 9 months to reach the red planet, and once there, astronauts may spend many months or even years before returning to Earth. These extended periods away from loved ones and familiar environments can lead to mental health challenges, such as depression, anxiety, and stress. Addressing these psychological challenges is crucial for the success of long-duration missions. Space agencies are already studying ways to maintain the mental well-being of astronauts. For example, the NASA Behavioral Health Program works to ensure that astronauts are mentally prepared for the isolation and confinement of space missions. The program includes training, mental health support, and team-building exercises to help astronauts cope with the stresses of space travel. In addition, researchers are studying ways to provide virtual reality experiences and entertainment to help astronauts maintain a sense of connection to Earth during long missions. But survival in space goes beyond just physical and psychological challenges. Another pressing concern is the cost of space exploration. Developing the technologies required for long-term space travel, building sustainable habitats, and maintaining life support systems all come with an enormous price tag. As we look to establish a permanent presence on the Moon and venture to Mars, space agencies and private companies will need to find ways to make space exploration financially viable. This will likely involve international collaboration, as the cost of space missions is simply too high for any one nation or organization to bear alone. One possible solution to this problem lies in the growing role of private companies in space exploration. Companies like SpaceX, Blue Origin, and Virgin Galactic are driving innovation in space technology and significantly reducing the cost of space travel. SpaceX's Starship, for example, is designed to be fully reusable, which could dramatically lower the cost of launching payloads and astronauts into space. By reducing the cost of access to space, private companies could help unlock new possibilities for exploration and settlement beyond Earth. But private companies alone cannot shoulder the burden of space exploration. Government space agencies, such as NASA and the European Space Agency, ESA, will still play a crucial role in supporting large-scale missions and providing essential infrastructure. In the coming decades, we are likely to see an increasing public-private partnership model, where government space agencies work closely with private companies to achieve common goals. This partnership could involve sharing resources, technology, and knowledge, with the goal of making space exploration more sustainable and accessible. At the same time, the global collaboration required for space exploration will need to be more robust than ever. As nations around the world turn their attention to the stars, there is an opportunity to work together to pool resources and expertise in a way that benefits all of humanity. The International Space Station, ISS, is a prime example of the power of international cooperation in space. Launched in 1998, the ISS is a joint project involving NASA, the Russian Federal Space Agency, Roscosmos, the European Space Agency, ESA, the Japan Aerospace Exploration Agency, JAXA, and the Canadian Space Agency, CSA. The ISS has been a platform for scientific research, technology development, and the fostering of peaceful cooperation in space. It serves as a reminder that, despite our differences, when we work together, we can achieve great things. Looking to the future, the role of artificial intelligence, AI, will be indispensable in overcoming the challenges of space exploration. AI has already begun to play a significant role in space missions, from analyzing vast amounts of data to controlling spacecraft and robots. As missions to the Moon, Mars, and beyond grow more complex, AI will help ensure that spacecraft can make decisions autonomously, respond to emergencies, and operate in environments that are far beyond human reach. AI will also assist in the management of space habitats, helping to monitor life support systems and even assist with scientific research and resource management. The potential applications of AI in space exploration are limitless. In the not-too-distant future, AI could assist astronauts in extravehicular activities, EVAs, the dangerous work that astronauts do outside their spacecraft or habitats. AI could help design advanced tools, assist with repairs, and even provide real-time analysis of the environment, ensuring astronauts' safety. Moreover, AI-powered robots could be used to explore planets, moons, and asteroids in ways that humans cannot, unlocking new frontiers of discovery. As we move toward becoming an interplanetary species, the technological advances and international cooperation required for space exploration will change the very fabric of our society. Space exploration has the potential to reshape the global economy, inspire future generations, and solve some of the most pressing challenges here on Earth. As humanity continues to advance into the cosmos, we are confronted not only with the technological and logistical challenges of space exploration, but with some of the most profound philosophical questions of our existence. What is our place in the universe? Are we alone, or do other intelligent civilizations exist out there, waiting to be discovered? These are questions that have haunted humankind for centuries, and space exploration offers us the unique opportunity to search for answers. One of the most intriguing aspects of modern space exploration is the search for extraterrestrial life. For decades, scientists have wondered whether life exists beyond Earth, whether it exists in our own solar system or on distant exoplanets orbiting faraway stars. The discovery of even the most basic forms of life beyond Earth would be one of the most groundbreaking achievements in the history of science, forever altering our understanding of life, the universe, and our place within it. The search for life in our solar system has already begun. Mars, with its cold, dry landscape and evidence of past water, has long been a target of exploration. NASA's Perseverance rover, which landed on Mars in 2021, is specifically tasked with searching for signs of ancient microbial life in the Martian soil. It is exploring the Jezero crater, an ancient lakebed, where it's believed that liquid water may have once existed. If signs of ancient life are found, it would indicate that life could have arisen independently on Mars, offering a glimpse into how life might begin on other worlds. But Mars is not the only target in the search for extraterrestrial life. Moons such as Europa, one of Jupiter's satellites, and Enceladus, one of Saturn's moons, have both been identified as potential havens for life. These moons harbor vast underground oceans beneath their icy surfaces. The conditions in these oceans could be conducive to life, and future missions will likely aim to explore these environments more thoroughly. NASA's Europa Clipper mission, scheduled to launch in the 2020s, will explore Europa's icy surface, analyzing its composition and looking for signs of subsurface water and chemical ingredients necessary for life. But the search for life doesn't end with the moons of our solar system. In recent years, scientists have turned their attention to exoplanets, planets that orbit stars outside our solar system. The discovery of thousands of exoplanets has opened up new possibilities in the search for extraterrestrial life. Some of these exoplanets are located in what's known as the habitable zone, the region around a star where conditions might be right for liquid water to exist on the planet's surface, a key ingredient for life as we know it. One of the most exciting discoveries in this field came with the detection of Proxima b, a planet orbiting the star Proxima Centauri, which is just over 4 light-years away from Earth. Proxima b is within the habitable zone of its star and could potentially support liquid water. While we don't yet know if life exists there, the discovery of a potentially habitable exoplanet so close to Earth raises the tantalizing possibility that we might one day find life just beyond our cosmic doorstep. The James Webb Space Telescope, set to launch in the coming years, will revolutionize our ability to detect and study exoplanets. Equipped with advanced instruments capable of analyzing the atmospheres of distant planets, Webb will allow scientists to search for signs of biosignatures, chemical indicators that life may exist on these distant worlds. The search for extraterrestrial life is not just a scientific endeavor, it's a quest that could fundamentally change how we view ourselves and our place in the universe. But the questions of life in the cosmos don't stop there. The search for intelligent extraterrestrial life, civilizations capable of advanced technology, has long been a subject of fascination. Could there be civilizations out there, millions of light-years away, capable of communicating with us? If so, why haven't we detected them yet? These questions have led to the development of the Search for Extraterrestrial Intelligence, SETI, an effort to listen for signals from alien civilizations. While no definitive signals have been detected, the search continues, with astronomers scanning the skies for any evidence of artificial radio waves or other forms of communication. The search for intelligent life is also tied to the Fermi paradox, the apparent contradiction between the high probability of extraterrestrial civilizations existing in the universe and the lack of evidence for their existence. Some scientists suggest that advanced civilizations might be out there, but they are either too far away, too different from us to detect, or perhaps deliberately avoiding contact. Others believe that we may be among the first intelligent civilizations to rise in the universe, and that the vast distances and technological barriers prevent us from making contact with others. As we look to the future, the role of artificial intelligence, AI, in space exploration and the search for life cannot be overstated. AI is already being used to help analyze vast amounts of data from space telescopes and rovers. It can sift through signals, identify patterns, and make connections that would be impossible for human scientists to detect on their own. As we continue to probe the depths of space and search for life, AI will be an invaluable tool in helping us unlock the mysteries of the cosmos. But as we search for life, we must also consider the possibility that humanity itself may be the key to discovering life in the universe. Could the act of sending out spacecraft and probes be our first step in making contact with alien civilizations? Could our presence in space be an invitation to the universe to reach out to us? The idea that humanity might one day join a cosmic community of civilizations is a thought-provoking concept that challenges our understanding of what it means to be human. As we send missions to other planets, moons, and stars, we may one day look up at the stars and realize that we are not alone. Yet, despite the excitement and optimism surrounding space exploration, there are still many unknowns. There is no guarantee that we will find life, let alone intelligent life. And even if we do find signs of life, we may not fully understand what it means or how to interact with it. But that uncertainty is part of what makes the search for extraterrestrial life so fascinating. It forces us to confront the unknown, to question our assumptions, and to broaden our understanding of the universe. As humanity continues to explore the cosmos, the search for life is more than just a scientific endeavor. It is a deeply philosophical pursuit that asks us to reflect on who we are, what we are capable of, and what our place in the universe might be. Whether we are searching for microbes beneath the ice on Europa or listening for alien signals from distant stars, the quest for life in the cosmos is a journey that will shape the future of humanity and forever change the way we view ourselves in the vastness of space. As we press forward in our quest to explore the stars and uncover the mysteries of the universe, we are also forced to consider the long-term future of humanity in space. The technological challenges of sending humans to distant worlds are daunting, but there are also profound philosophical questions about our place in the cosmos. If humanity is to become a spacefaring species, what role will we play in the broader narrative of the universe? Will we be explorers and settlers, or will we become part of something much larger than ourselves, perhaps the beginning of a new era of cosmic civilization? The idea of human colonization of other planets has long been a dream. Whether it's the Moon, Mars, or even the moons of Jupiter and Saturn, the notion of establishing self-sustaining colonies beyond Earth has captivated imaginations for generations. With every technological breakthrough and every new rover sent to the surface of a distant world, this dream becomes a little more tangible. But colonization, while exciting, is also fraught with difficult questions. What happens to the social, political, and economic structures of humanity when we spread out across the stars? One possibility is the establishment of independent colonies on other worlds. Imagine a thriving colony on Mars, with its own government, economy, and unique cultural identity. While Earth would remain our home planet, these colonies could develop in ways that are radically different from the society we know today. The very act of living on another world would require a new way of thinking, a new approach to sustainability, resource management, and survival in an environment that is completely different from Earth's. Mars, with its cold, arid landscape and thin atmosphere, will require innovation and adaptation for humans to thrive. Colonists will need to build habitats that can withstand the harsh conditions, use local resources to produce food, water, and oxygen, and find ways to shield themselves from harmful radiation. These colonies will be far from self-sufficient at first, relying on Earth for supplies and support. But over time, they will have the potential to grow and evolve, creating a new society that may look and function very differently from the one we left behind. Beyond Mars, there is the possibility of terraforming, the idea that we could alter the environment of a planet or moon to make it more hospitable to human life. Terraforming Mars, for example, could involve warming its atmosphere, introducing greenhouse gases, and possibly even building an artificial magnetic field to protect the planet from solar radiation. This is an ambitious goal, one that may take centuries or even millennia to accomplish, but it could make Mars a viable place for human habitation, transforming it from a barren desert world into a new Earth. While Mars may be the first target for colonization, other destinations in the solar system could also hold promise. Europa, one of Jupiter's moons, is believed to have an ocean beneath its icy surface. This could potentially support life, and it might offer a wealth of resources for future human exploration. Titan, Saturn's largest moon, has an atmosphere and liquid methane lakes. Titan presents unique challenges, but could become an interesting location for scientific research and human settlement. As we continue to explore the solar system, we may find even more places that could one day support human life. But space colonization is not without its ethical questions. As we venture into the cosmos, we must ask ourselves, should we be altering other planets and moons to make them habitable for humans? What is our responsibility to preserve the natural environments of these worlds? Are we repeating the same mistakes of environmental degradation that we made on Earth, but on a cosmic scale? These are important questions that will need to be addressed as we embark on the next great era of human exploration. In addition to the question of colonization, we also face the broader existential question of what it means to be human in an infinite universe. When we look up at the stars, it's easy to feel both insignificant and awestruck. The vastness of the cosmos makes Earth seem small, and yet, it is our home. In the grand scheme of the universe, we are a tiny speck, but our consciousness, our ability to understand and explore the universe, sets us apart. If we are able to travel to distant stars and planets, what does that say about our species? Will humanity be defined by the worlds we conquer, or by the knowledge we gain about the universe and ourselves? The questions we ask in space exploration are not only about finding life or new resources, but about finding meaning in our existence. If we make contact with intelligent extraterrestrial life, how will that change our understanding of what it means to be human? If we discover that we are alone in the universe, how will we cope with the knowledge that we are the only intelligent beings in a vast, empty cosmos? For many, the search for life beyond Earth is more than just a scientific endeavor, it's a journey of self-discovery. The search for life in the cosmos is, in a sense, the search for answers to the deepest questions of human existence. Are we alone? What is the purpose of our lives? What does the future hold for humanity as we expand beyond the confines of Earth? As we continue to explore the stars, we will face difficult challenges, both technical and philosophical. The technological innovations required to survive and thrive in space will push the boundaries of what is possible, while the questions we ask will push the boundaries of what we know about ourselves. In the end, space exploration is not just about the destination, it's about the journey. It's about pushing the limits of human potential and reaching for something greater than ourselves. And as we venture into the cosmos, we will be forever changed. We will discover new worlds, new possibilities, and perhaps even new forms of life. But the greatest discovery of all may be the understanding of our place in the universe, and the realization that we are not just inhabitants of Earth, we are citizens of the cosmos, destined to explore, discover, and create a future beyond the stars. As humanity stretches farther into the cosmos, the technological advancements driving this exploration are nothing short of revolutionary. Every new mission into space brings with it groundbreaking technology, new materials, and innovative methods that push the boundaries of what we once thought was possible. These innovations not only aid our exploration of distant worlds, but also hold the key to humanity's survival and future in space. But what does the future of space exploration look like? And what role will technology play in unlocking the mysteries of the universe? To understand the future of space exploration, we must first look at the technologies that will make it possible. The most fundamental challenge of space travel is overcoming the vast distances between us and the stars. Even within our own solar system, the distances are staggering. The average distance from Earth to Mars is about 225 million kilometers, and it would take a spacecraft about 6 to 9 months to make the journey. To reach distant stars, the distances are measured in light years, with 1 light year being the distance that light travels in a year, approximately 9.46 trillion kilometers. If humanity is to become a true spacefaring civilization, we need new methods of propulsion, faster travel, and more efficient ways of reaching far-off destinations. One of the most promising technologies in this field is nuclear propulsion. Nuclear-powered spacecraft could significantly reduce the time it takes to travel to distant planets and even nearby stars. Nuclear thermal propulsion, NTP, uses nuclear reactions to heat a propellant, such as hydrogen, and expel it through a nozzle to generate thrust. This would allow for faster and more efficient travel compared to conventional chemical rockets. With NTP, a mission to Mars could potentially be shortened by several months, drastically improving the feasibility of human exploration of the red planet. Another exciting development is ion propulsion, a technology already being tested on spacecraft like NASA's Dawn mission. Ion propulsion works by using electricity to ionize a propellant, like xenon gas, and then expelling the ions at high speeds to create thrust. While ion engines produce much less thrust than conventional chemical rockets, they are incredibly efficient and can operate for long periods of time. This makes them ideal for deep space missions, where efficiency and endurance are critical. Ion propulsion is already helping spacecraft like Dawn to reach distant asteroids, and it may one day be key to exploring the outer reaches of the solar system and beyond. In addition to propulsion technology, the materials used in spacecraft are also evolving. Lightweight, durable materials like carbon composites and nanomaterials are being developed to withstand the harsh environment of space, providing better protection for astronauts and equipment. Spacecraft are becoming more resilient to radiation, micrometeorite impacts, and extreme temperatures. These materials not only make missions safer but also reduce the overall weight of spacecraft, allowing them to carry more supplies and equipment on their journeys. As we think about human exploration, the need for habitation modules capable of sustaining life for long periods in space becomes even more pressing. To survive on Mars or the Moon, astronauts will need protection from radiation, oxygen to breathe, food to eat, and water to drink. While Earth's atmosphere protects us from harmful radiation, space explorers must rely on advanced radiation shielding to safeguard their health. This could involve building habitats made of regolith, the loose soil found on the Moon and Mars, using advanced materials, or even creating magnetic shields that simulate Earth's magnetic fields to protect against solar and cosmic radiation. Another key technology for human exploration of other worlds is life support systems that can recycle air, water, and waste. On missions that last months or years, carrying supplies from Earth is impractical. Instead, astronauts will need to rely on closed-loop systems that recycle resources, making them more self-sufficient. NASA has already developed and tested these systems on the International Space Station, ISS, and they will be essential for long-term space exploration. By mimicking the Earth's biosphere, these systems will ensure that astronauts can breathe clean air, drink water, and grow food, without relying on Earth for regular resupply missions. Beyond these technologies, artificial intelligence, AI, is playing an increasingly important role in space exploration. AI systems can assist with navigation, system monitoring, and even decision-making. For example, the Mars rovers, such as Curiosity and Perseverance, use AI to analyze their surroundings, make decisions about where to go next, and avoid obstacles. In the future, AI could play a critical role in managing the complex operations of spacecraft, colonies, and missions, making space exploration more efficient and safer for human explorers. Moreover, robotics is another key technology that will shape the future of space exploration. Robotic explorers, like the rovers on Mars and the landers sent to the Moon, are already paving the way for human missions. These robots gather essential data, explore distant surfaces, and even perform repairs on spacecraft. As technology advances, we can expect even more sophisticated robots capable of performing complex tasks like construction on Mars or asteroid mining. These robots will not only assist astronauts but also lay the groundwork for long-term human presence on distant worlds. The growing role of private companies is also revolutionizing the space industry. Companies like SpaceX, Blue Origin, and Virgin Galactic are pushing the envelope when it comes to commercial space travel. SpaceX, in particular, has made significant strides with its Starship program, aiming to develop fully reusable spacecraft for missions to the Moon, Mars, and beyond. As private companies partner with NASA and other space agencies, the cost of space exploration is expected to decrease, making space travel more accessible and allowing for an era of space tourism and potentially even space colonization. Looking to the future, we might one day see interstellar travel, the idea of sending probes or even human missions to other star systems. While current technology is far from being able to achieve this, new concepts like solar sails, which use the pressure of sunlight to propel spacecraft, or even theoretical concepts like the Alcubierre drive, a hypothetical faster-than-light propulsion method, might one day allow humanity to venture to other star systems and explore the unknown regions of the cosmos. With these technologies, the future of space exploration is bright. From the exploration of Mars to the search for life on Europa, from the development of advanced propulsion systems to the establishment of colonies on distant worlds, we stand at the threshold of a new era. As humanity continues to advance into the cosmos, we are confronted not only with the technological and logistical challenges of space exploration, but with some of the most profound philosophical questions of our existence. What is our place in the universe? Are we alone, or do other intelligent civilizations exist out there, waiting to be discovered? These are questions that have haunted humankind for centuries, and space exploration offers us the unique opportunity to search for answers. One of the most intriguing aspects of modern space exploration is the search for extraterrestrial life. For decades, scientists have wondered whether life exists beyond Earth, whether it exists in our own solar system or on distant exoplanets orbiting faraway stars. The discovery of even the most basic forms of life beyond Earth would be one of the most groundbreaking achievements in the history of science, forever altering our understanding of life, the universe, and our place within it. The search for life in our solar system has already begun. Mars, with its cold, dry landscape and evidence of past water, has long been a target of exploration. NASA's Perseverance rover, which landed on Mars in 2021, is specifically tasked with searching for signs of ancient microbial life in the Martian soil. It is exploring the Jezero crater, an ancient lakebed, where it's believed that liquid water may have once existed. If signs of ancient life are found, it would indicate that life could have arisen independently on Mars, offering a glimpse into how life might begin on other worlds. But Mars is not the only target in the search for extraterrestrial life. Moons such as Europa, one of Jupiter's satellites, and Enceladus, one of Saturn's moons, have both been identified as potential havens for life. These moons harbor vast underground oceans beneath their icy surfaces. The conditions in these oceans could be conducive to life, and future missions will likely aim to explore these environments more thoroughly. NASA's Europa Clipper mission, scheduled to launch in the 2020s, will explore Europa's icy surface, analyzing its composition and looking for signs of subsurface water and chemical ingredients necessary for life. But the search for life doesn't end with the moons of our solar system. In recent years, scientists have turned their attention to exoplanets, planets that orbit stars outside our solar system. The discovery of thousands of exoplanets has opened up new possibilities in the search for extraterrestrial life. Some of these exoplanets are located in what's known as the habitable zone, the region around a star where conditions might be right for liquid water to exist on the planet's surface, a key ingredient for life as we know it. One of the most exciting discoveries in this field came with the detection of Proxima b, a planet orbiting the star Proxima Centauri, which is just over 4 light-years away from Earth. Proxima b is within the habitable zone of its star and could potentially support liquid water. While we don't yet know if life exists there, the discovery of a potentially habitable exoplanet so close to Earth raises the tantalizing possibility that we might one day find life just beyond our cosmic doorstep. The James Webb Space Telescope, set to launch in the coming years, will revolutionize our ability to detect and study exoplanets. Equipped with advanced instruments capable of analyzing the atmospheres of distant planets, Webb will allow scientists to search for signs of biosignatures, chemical indicators that life may exist on these distant worlds. The search for extraterrestrial life is not just a scientific endeavor, it's a quest that could fundamentally change how we view ourselves and our place in the universe. But the questions of life in the cosmos don't stop there. The search for intelligent extraterrestrial life, civilizations capable of advanced technology, has long been a subject of fascination. Could there be civilizations out there, millions of light years away, capable of communicating with us? If so, why haven't we detected them yet? These questions have led to the development of the Search for Extraterrestrial Intelligence, SETI, an effort to listen for signals from alien civilizations. While no definitive signals have been detected, the search continues, with astronomers scanning the skies for any evidence of artificial radio waves or other forms of communication. The search for intelligent life is also tied to the Fermi paradox, the apparent contradiction between the high probability of extraterrestrial civilizations existing in the universe and the lack of evidence for their existence. Some scientists suggest that advanced civilizations might be out there, but they are either too far away, too different from us to detect, or perhaps deliberately avoiding contact. Others believe that we may be among the first intelligent civilizations to rise in the universe, and that the vast distances and technological barriers prevent us from making contact with others. As we look to the future, the role of artificial intelligence, AI, in space exploration and the search for life cannot be overstated. AI is already being used to help analyze vast amounts of data from space telescopes and rovers. It can sift through signals, identify patterns, and make connections that would be impossible for human scientists to detect on their own. As we continue to probe the depths of space and search for life, AI will be an invaluable tool in helping us unlock the mysteries of the cosmos. But as we search for life, we must also consider the possibility that humanity itself may be the key to discovering life in the universe. Could the act of sending out spacecraft and probes be our first step in making contact with alien civilizations? Could our presence in space be an invitation to the universe to reach out to us? The idea that humanity might one day join a cosmic community of civilizations is a thought-provoking concept that challenges our understanding of what it means to be human. As we send missions to other planets, moons, and stars, we may one day look up at the stars and realize that we are not alone. Yet, despite the excitement and optimism surrounding space exploration, there are still many unknowns. There is no guarantee that we will find life, let alone intelligent life. And even if we do find signs of life, we may not fully understand what it means or how to interact with it. But that uncertainty is part of what makes the search for extraterrestrial life so fascinating. It forces us to confront the unknown, to question our assumptions, and to broaden our understanding of the universe. Building human colonies on the Moon, Mars, or even farther afield is no longer just a dream, it's becoming a tangible goal. However, the reality of creating sustainable habitats in space presents numerous challenges. The conditions on these worlds are vastly different from those we experience on Earth, requiring innovative solutions to ensure that humans can live and thrive in the harsh environments of space. The first challenge, and perhaps the most pressing, is surviving the harsh environments of space. The lack of atmosphere, extreme temperatures, and high levels of radiation make it impossible for humans to survive without proper protection. On Mars, for instance, temperatures can drop as low as -125 degrees Celsius during the night, and the surface is constantly bombarded with harmful radiation from the sun and cosmic rays. Even on the Moon, which has no atmosphere to speak of, temperatures can vary wildly between scorching heat in the daytime and freezing cold at night. To overcome these obstacles, the construction of habitats that provide life support and protection is essential. These habitats must be self-sustaining, providing astronauts with everything they need to survive, including air, water, and food. One proposed solution is to use the natural resources of the land itself, something known as in situ resource utilization, ISRU. For example, lunar habitats could be built using the Moon's regolith, the loose dust and rock that covers the lunar surface. Regolith can be turned into building materials like bricks or concrete, which could be used to construct protective domes or underground habitats that shield inhabitants from radiation and temperature extremes. Similarly, on Mars, subsurface habitats might be the most effective option for long-term habitation. Building underground facilities would provide natural protection from the planet's harsh radiation and temperature swings. These habitats could also make use of Mars water ice deposits, which could be mined to provide water for the inhabitants and, through electrolysis, oxygen for breathing. As technology advances, creating a closed-loop life support system that can recycle air, water, and waste will be vital to maintaining a sustainable colony. Another crucial aspect of colonization is the generation of food. Transporting large quantities of food from Earth to space is not feasible, so future space settlers will need to grow their own. This is where hydroponics and aeroponics, methods of growing plants without soil, come into play. These systems allow crops to be grown in nutrient-rich water or mist, which can save space and reduce the need for soil. Researchers are already experimenting with growing crops like lettuce, tomatoes, and potatoes on the International Space Station, ISS, and these techniques will likely be key to sustaining colonies on the Moon or Mars. However, food production is just one part of the equation. The health and well-being of astronauts in space will be equally important. Long-term space missions can have a significant impact on human health, particularly when it comes to muscle and bone loss due to the lack of gravity. On Earth, gravity constantly exerts pressure on our muscles and bones, helping them remain strong. In the microgravity environment of space, however, astronauts experience muscle atrophy and bone density loss. To counter this, astronauts on the ISS perform daily exercise routines, including weightlifting and cardiovascular workouts, to maintain their health. Similarly, colonists on Mars or the Moon will need to adopt strict exercise regimens to keep their muscles and bones strong. Beyond physical health, the mental health of colonists will be just as critical. Isolation, confinement, and the extreme distance from Earth can take a toll on an astronaut's psychological well-being. The long journey to Mars alone could take anywhere from 6 to 9 months, followed by years spent on a distant planet with limited human interaction. Research into the psychological effects of space travel is ongoing, and many space agencies are developing strategies to help astronauts cope with stress, isolation, and the potential for conflicts within small crews. One approach is to create a sense of community and connection. Regular communication with family and loved ones back on Earth, through messages, video calls, or even virtual reality experiences, could help maintain mental well-being. Additionally, the design of the habitat itself can play a role in promoting mental health. Providing astronauts with private spaces, recreational activities, and a way to stay connected with nature, through plant growth or simulated environments, can help combat the feelings of isolation. Finally, transportation to and from these colonies will be another challenge. While current rockets can send humans to space, they are still far too slow and inefficient for long-term missions. Developing more efficient propulsion systems, such as nuclear thermal propulsion or ion drives, could reduce travel time and make trips to Mars or the Moon more feasible. As we move toward more routine missions to the Moon and beyond, the technology for space travel will continue to improve, making human colonization of distant worlds more realistic. These developments in space infrastructure, including the creation of sustainable habitats, food production systems, and transportation networks, are not just theoretical, they are already in progress. The Artemis program, led by NASA, aims to return humans to the Moon by the 2020s and establish a sustainable human presence there by the 2030s. Meanwhile, SpaceX's Starship is designed to carry large numbers of people and cargo to the Moon, Mars, and beyond. With these advancements, the dream of human colonies on other worlds is moving closer to becoming a reality. Human space exploration is advancing at a pace never seen before. Each breakthrough in technology brings us one step closer to becoming a multiplanetary species, and with that comes a need to continually innovate. From advanced propulsion systems to cutting-edge life support technologies, the future of space travel is being shaped by innovations that have the potential to not only change how we explore the cosmos but also how we live and work in space. One of the most significant breakthroughs in space exploration technology is propulsion. For years, the only way to send spacecraft into deep space was through conventional chemical rockets. While they are reliable, these rockets are limited in terms of efficiency and speed. To truly explore distant planets like Mars, or even moons like Europa, we need propulsion systems that can travel faster and more efficiently. Enter nuclear propulsion, a game-changer in space travel. Nuclear thermal propulsion, NTP, works by heating a propellant, such as hydrogen, using nuclear reactors, which is then expelled to create thrust. This method offers a much higher efficiency than chemical rockets, meaning that spacecraft can travel faster and carry more cargo. A nuclear-powered spacecraft could drastically reduce the travel time to Mars, potentially cutting a mission down from 9 months to just a few months. In addition to NTP, there are also experimental ideas like ion thrusters, which use electric fields to accelerate ions to produce thrust. While ion thrusters generate much less thrust than chemical or nuclear engines, they can operate for much longer periods, making them ideal for missions that require prolonged space travel. Another area where technology is making huge strides is in life support systems. In the early days of space exploration, astronauts relied on bulky systems to supply them with oxygen and remove carbon dioxide. These systems were not only heavy but also limited in their ability to be sustained over long periods. Now, engineers are developing closed-loop life support systems that recycle air and water, allowing for long-duration missions with minimal resupply from Earth. NASA's Environmental Control and Life Support Systems, ECLSS, aboard the International Space Station, ISS, have been key in advancing this technology. This system collects and filters the astronauts' waste water, purifies it, and recycles it back into drinking water. In the future, similar technologies will be used on Mars, where resupply missions will be infrequent, making it essential to reuse resources to sustain a colony. While the recycling of water and air is crucial for space missions, so is food production. In the past, astronauts relied on prepackaged meals, but this approach is not sustainable for long-term missions. As humans prepare to establish permanent colonies on Mars, growing food in space will be a necessity. Hydroponic and aeroponic farming have shown tremendous promise for growing crops without soil. These systems use nutrient-rich water or mist to nourish plants, providing fresh food for astronauts while requiring far less space than traditional farming methods. NASA has been testing these techniques on the ISS, growing vegetables like lettuce, spinach, and radishes in controlled environments. Eventually, these technologies will be essential for Mars missions, where astronauts will need to grow their own food to survive. However, it's not just about growing food, it's about creating a balanced diet. The challenge lies in growing enough diverse crops to provide the necessary nutrients for a healthy, well-rounded diet. Space food research is focusing on creating food that can be stored and preserved for extended periods, but also ensuring that astronauts' meals provide essential vitamins, minerals, and protein. In addition to food and life support, communication technologies are also evolving. For current missions, sending data to and from space takes time. Messages sent from Mars to Earth, for example, can take anywhere from 13 to 24 minutes, depending on the planet's positions. As we establish more distant colonies and missions, this delay will present significant challenges. To solve this, scientists are working on improving deep space communication systems, such as the laser communications technology that NASA has been testing. Laser-based systems can transmit data at much higher rates than traditional radio waves, allowing for faster communication and more efficient use of bandwidth. This will be essential for maintaining contact with crews on Mars, the Moon, or beyond, especially when human missions are far away from Earth. Spacecraft themselves are also undergoing revolutionary changes. Traditional spacecraft have been relatively small, designed for short missions and carrying a limited number of astronauts. But with the goal of building colonies on Mars, spacecraft will need to be much larger and capable of carrying more passengers and supplies. SpaceX's Starship is one such craft that has been designed with this purpose in mind. It is capable of carrying up to 100 passengers, along with all the necessary cargo, to the Moon, Mars, or even beyond. The Starship is fully reusable, which means it can be launched and landed multiple times, reducing the cost of space travel and making space exploration more sustainable. In addition to larger spacecraft, we also need space habitats that can provide everything a colony needs to survive. These habitats need to be built to withstand extreme conditions, including radiation, temperature fluctuations, and the absence of gravity. Companies like Bigelow Aerospace are already developing inflatable modules that can be used as habitats on the Moon and Mars. These inflatable habitats are lighter, easier to transport, and can be expanded once they reach their destination, providing astronauts with ample living space. As we continue to develop these technologies, we must also consider the ethical implications of space exploration. While space exploration brings humanity closer to the stars, it also raises important questions about the ownership of space resources, the treatment of potential extraterrestrial life, and the environmental impact of human activities beyond Earth. As new technologies become available, we will need to create international agreements and policies to ensure that space exploration benefits all of humanity, not just a few privileged nations or corporations. While human space exploration has made remarkable strides within our solar system, the dream of traveling to other stars remains far beyond our reach, at least for now. The vast distances between stars make interstellar travel one of the most daunting challenges in the history of space exploration. Even the closest star system, Alpha Centauri, lies over 4 light-years away, a journey that would take current spacecraft thousands of years to complete. Yet, scientists and engineers are not deterred. Instead, they are looking to new and innovative technologies that could make interstellar travel a reality within this century. The key to unlocking interstellar exploration lies in advancements in propulsion. As we've already seen, current chemical propulsion systems are far too slow to reach even the nearest stars in a human lifetime. But new propulsion methods are being studied that could revolutionize space travel and make journeys to distant stars feasible. One of the most promising concepts is fusion propulsion. Fusion is the process that powers the Sun, where hydrogen atoms combine to form helium, releasing enormous amounts of energy. If we can harness this energy on Earth, fusion could provide a nearly unlimited source of power, potentially powering spacecraft for interstellar journeys. Fusion propulsion could propel spacecraft at a fraction of the speed of light, drastically reducing travel time to distant star systems. While fusion reactors are still in the experimental stage, breakthroughs in fusion energy could pave the way for the propulsion systems of tomorrow. Another concept gaining traction is solar sails. Solar sails use the pressure from sunlight to push a spacecraft forward, providing continuous acceleration without the need for fuel. The idea is simple but powerful. Large, thin sails are deployed, and as photons from the sun hit the surface, they impart momentum, gradually pushing the spacecraft toward its destination. Solar sails have already been tested with small probes like the Breakthrough Starshot initiative, which aims to send lightweight spacecraft to Alpha Centauri at up to 15 to 20% of the speed of light. While these probes are not designed for human travel, the technology could eventually be adapted for larger missions. The concept of antimatter propulsion is another frontier that could revolutionize space travel. Antimatter is the opposite of normal matter. When matter and antimatter meet, they annihilate each other, releasing vast amounts of energy. If we could find a way to harness this energy, it could potentially propel spacecraft at near-light speeds. While antimatter is incredibly difficult to produce and store, scientists are exploring ways to make it more accessible, and the possibility of using antimatter as a fuel source for interstellar missions remains an exciting, albeit distant, prospect. However, it's not just propulsion that needs to evolve for interstellar travel to be feasible. The life support systems on long-duration missions must also be reimagined. While current life support systems are designed for relatively short trips, interstellar missions would require spacecraft capable of sustaining astronauts for decades, or even centuries. Researchers are investigating ways to create closed-loop ecosystems on board spacecraft, where resources like water, air, and food are constantly recycled and replenished. Additionally, new advances in artificial intelligence, AI, could help manage these systems, ensuring that everything runs smoothly during long missions. One of the biggest obstacles for interstellar exploration, aside from propulsion and life support, is the sheer distance between stars. Even at a significant fraction of the speed of light, it would still take decades to reach other star systems. To overcome this, generation ships could be a solution. A generation ship is a spacecraft large enough to support multiple generations of astronauts, with descendants of the original crew continuing the journey after their predecessors have passed. This idea, though far-fetched, has been explored in science fiction, and while it may seem like an extreme solution, it may one day be necessary for humanity to explore the stars. Additionally, artificial intelligence and robotics could play an essential role in interstellar exploration. AI could help manage long-duration missions, assist in scientific research, and make real-time decisions for spacecraft traveling to distant star systems. These intelligent systems could also be responsible for constructing and maintaining habitats or infrastructure on distant planets or moons. Robotics would allow for exploration of alien worlds without risking human lives, sending rovers and drones to gather data, analyze terrain, and even mine resources. But before humanity sets off on interstellar voyages, we must first explore our immediate neighborhood in space. The James Webb Space Telescope and other upcoming space observatories are helping scientists study exoplanets orbiting distant stars, some of which may be capable of supporting life. These missions will be essential for identifying potentially habitable planets that could serve as future destinations for interstellar travel. The question of whether life exists elsewhere in the universe remains unanswered, but the search for extraterrestrial life continues to drive our curiosity. Missions like SETI, Search for Extraterrestrial Intelligence, are working to detect signals from intelligent civilizations, and telescopes are constantly scanning the cosmos for signs of life. The discovery of even microbial life on Mars or one of the icy moons of Jupiter or Saturn would have profound implications for our understanding of life in the universe. As we look toward the future, the pursuit of interstellar travel will continue to push the boundaries of technology, exploration, and human potential. Each advancement brings us closer to answering age-old questions about the nature of the universe and our place within it. And while interstellar travel may be a distant dream today, the possibilities for future generations of explorers are limitless. The future of space exploration, whether it's reaching the stars or discovering new worlds closer to home, is an exciting frontier that will captivate and inspire us for years to come. As we stand at the precipice of this new era of space exploration, we are reminded that humanity's quest to explore the cosmos is not just about advancing technology. It's about expanding our horizons, reaching beyond what we know, and unlocking the mysteries of the universe. The challenges are immense, but the possibilities are even greater. From the early days of space travel to the planned missions to Mars, the journey to the stars has been one of humanity's greatest achievements. The Apollo missions that first landed humans on the Moon proved that we are capable of overcoming seemingly insurmountable obstacles and achieving the unimaginable. The International Space Station, ISS, is a testament to international cooperation and the human spirit of exploration. And now, with advancements in propulsion, life support systems, and artificial intelligence, the dream of reaching other planets and even other star systems is no longer just science fiction, it is becoming a reality. But even as we venture further into the cosmos, we are reminded of the vastness of space and the challenges that lie ahead. The distances between stars are mind-boggling, and the potential dangers of space travel, cosmic radiation, micrometeoroids, and the unknowns of alien worlds are constant threats. Yet, it is precisely these challenges that drive us to innovate, to push the boundaries of what is possible, and to seek answers to the most fundamental questions of existence. What is out there? Are we alone in the universe? How did it all begin? These are questions that have plagued humanity for centuries. As we venture into the unknown, we begin to understand that space exploration is not just about discovering new worlds, it is about discovering ourselves. Each mission, each discovery, brings us closer to understanding our place in the vast expanse of the cosmos. The future of space exploration is bright. The next generation of astronauts, engineers, and scientists will continue to push the boundaries of what is possible, and their efforts will inspire generations to come. Whether it's sending humans to Mars, establishing colonies on the Moon, or sending probes to the outer reaches of the solar system, the potential for exploration is limitless. And as we unlock the secrets of space, we also unlock the potential for humanity to become a multiplanetary species, one that not only survives, but thrives among the stars. As we look to the future, the stars are not the limit. They are the beginning. The universe is vast, and with every step we take, we are closer to understanding the infinite mysteries it holds. The journey is just beginning, and humanity is poised to continue its exploration of the cosmos for generations to come. The final frontier is not a destination, it is an ongoing adventure, one that will define the future of humanity for centuries to come.